Hello and welcome to Vidush Academy. Today I'm going to present another series of live coding. This time I'm going to present a second chapter of this book time series, Forecasting in Python. The chapter is called A Naive Prediction of the Future. It's from part 1, Time Waits for No One. The editorial house is Manning, and if you're interested in buying the books with about 30% discount, you can take a look at the description of the video where you can find a discount code. So let's start. So what exactly is a naive prediction when we talk about forecasting? Well, in general, naive prediction is pretty much saying that if yesterday I was selling pretty much 100 items, next day I will be selling also 100 items. That's the most naive way, like nothing more. And another naive way is pretty much saying if the last period I was on average selling 1000 items, the next period would be the average of those 1000 items. So something else that I should probably note out is that the code I'm pretty much presenting is present here in GitHub of the book, so you can take a look there. It's most probably better looking, but I'll try to make it okay, not boring, I hope. Not that the one is boring, but yeah, you got me. Really, in short, what would you see if you stay up to the end of the video with me? Pretty much this is the end code, importing the stuff, importing the J&J CSV, which looks like this, and based on this data for real earning per share of Johnson & Johnson for 1960 to 1980, we are going to build a naive forecast into with Matplotlib and plot it. Okay, so this is how the head looks, how the tail of the data looks. And this is the most naive method to build it. Pretty much, we're not even building it here. We're simply dividing the data into two sets of training and test data. Training is this one, the left side. Test is the last 4 values. So here we are splitting it. And the first way to produce something is to build a historical mean. So with the historical mean, we are really failing to predict anything good, because the historical mean, as you see, is 4. So it's on average really bad. Our result is 70, which is kind of okay, not exactly a random number, but close to it. So as a second method, we go with the last year mean. Just the last year mean actually is quite okay compared to the all means. You see, like the result here is improving drastically up to 12, which is kind of good, but it's still not taking into account a lot of stuff. Like, for example, seasonality and the fact that we have here a down option. So as the next one, we go and we decide to just take the last value that we have, which is not good. Result is the map result here is kind of not good, but yeah, just a second. Yeah, 30, which is bad. And then the best thing that we come up is naive seasonal forecast, which actually says the following: just take the last 4 values and put them correspondingly as they are. So yeah, copy paste, but it works. You see the red is the predicted one, the blue is the real one. So at the end, our summary of the 4 naive methods for forecasting, it's obvious that the naive seasonal is by far the best one. So it's up to you. If you like, watch further. Okay, so we go into PyCharm. we go File, New Project. I'm not going to do a new project, I'm going File, New, and then Jupyter Notebook, and I'll call Naive Forecasting, and then yeah, Naive Forecasting is okay. So how do we start? First we import the libraries, import pandas as pd, import numpy as np, import matplotlib pyplot as plt. Shift and enter to see what's going on, and if it runs like this, it's perfect. Then the next thing is this beauty here. What does it do? I'll be honest with you, I just googled it. So mode chain assignment equals warn only causes warning messages to be printed, but no exception is raised. So I guess it's okay to be present there. The next thing that we are interested in is getting our data. So our data into a data frame is dataframe.pd.readCSV, and then depending on where we put it, we just may say jnj.csv. Okay, if we go here to the time series and we click on this place here in the Git on the root directory, we can go to the data and we can look for the jj.com. It's this one. It's a CSV data, so we can simply go on row, copy, then go in our place here, say okay, new, file is okay, it will be called jnj.csv, comma separated value. I'll simply paste it and I'll leave it with enter just to see how it will be. Okay, so df jnj.csv. I just pressed shift and enter and it gave me a problem that pandas has no attribute rate CSV. Of course it doesn't have this attribute rate CSV. Most probably I made some kind of a mistake. Yeah, it's read CSV. Yeah, and then we didn't find this directory jnj.csv. Okay, true, because it's looking here where the naive forecasting thing is. And it shouldn't be in it, but it's in the data folder. So it means that we should go one level up. One level up, we go with 2 dots. I'm just doing some stuff here while doing. Okay, 2 dots. And then we go data. And then we say no such file or directory, data jnj.csv. Okay, we don't need the 2 dots because we don't go up, and we also don't need the slash. Yes, and if we click just df, we get what we need. That's great. In the book, the author has used df head just to show us what he is presenting. Great, df head it is. Yeah, so except for df head, we can also use df tail. Yeah, and this is the head, the first 5, and the tail, the last 5. Okay, plot data train test slip. This is how we put markdown, pretty much like this, and we can do it beautifully. So the author starts with writing fig x put subplots. Pretty much I'm just copying and pasting to save time, but not in a hurry. So yeah, this is what we got. Fig and x equals these two. Let's see what the fig just presents. Fig, strange. Fig, just this AX. AX is obviously the class. Okay. And after doing this, we can start doing a bit more beauties like plot, df, date, and data. Df, data. Okay, what are these def and data? See, date are the dates that we're giving, the first day of the month. Yeah, this is like American style, so this is the month and this is the first day. And data is the return of share based of Johnson & Johnson for this specific month. So we put it like this, just to see, and we see, okay, pretty much on the first period it was somewhere here, 0.71, and on the last one it was 11.61. Yeah, pretty much this is how it looks like. What does it mean? It means that we just plotted our data. Okay. The next thing that we are doing is pretty much setting the X label, and we call it, of course, date. Here you see the small date appeared, and if we go to the AX set Y label, we're going to call it, okay, not return on investment, but earnings per share in dollars. Yeah. Or we can put it like, yeah, now it's okay. Or USD, as it was in the author's idea. Okay. A few more interesting things that we're going to do with our thing, with our plot graph, is that we're going to split our data into two separate sets, test data and training data. So test data would be this one, and training data would be everything else from 0 to 79, and the last 4 would be the test data. So based on the training data, we're going to come up with some kind of a logic in order to get the test data correct. Oh. And in order to plot it, the last 4 points here would be in gray. Let's see how we are going to do this. AX vSpan, pretty much we say from 80 to 83. So the last 4 would have the color, can write green, and the alpha, which is, I think, the see-through, is 0.2. Yeah, if we say from 55 from 83, it will be from here to there. But the logic is that we do it this way. And we can also, except for green, write some kind of magic numbers standing for R, G, and B, I guess. So R is this, G is this, B is that. So it's looking like this. And we should put something here on the X-ticks. What we can do, we can pretty much say, okay, our data starts from 9060 and it finishes on 9080. So for every 4 of those, I want to have a like a tick saying it. So because we are developers in general, we might think to do it the easy way, which is pretty much hard coding, or something else that I just tried here. Just a second to find it. Nope, I didn't find it, so I'm going to do it on the spot. So before doing, I can try to do it here. I'm gonna name it my years. and I'm looking, and it would be list, range, method, and then starting 9060, finishing 9080, and every 2 years seeing how it is going to see, and then of course plot it, or print it, not plot it. Okay, 78 is the last one, 9060 is the first one, and in the original ones we had 9060 and 9080, so it's going to be like 81 here, and we just got it. Yeah. Okay, so I'm going to put it here, my years, or even somewhere here. Okay, and I'm going to call it POT xticks np range 0, 81, 8, and then of course my years. See how it's gonna look. Okay, this is not a good idea. Let's see like this. The number of fixed locations 12, usually call from a set ticks, does not match the number of tick labels 11, and that's what we got. It's disgusting, but what can we do? I love it when this happens. Literally have the code in front of me, and I would even tried it like yesterday, and it still, yeah, somehow gives mistakes. Okay, 80 to 83, this is correct. Color is okay. Alpha. Number of fixed locations. Yeah, okay. Value error. This is what it doesn't like. POT xticks. Yeah. Could we try it like this? No, same. That's really interesting. And yeah, fixed locator should be 81 and then 8. Yeah. Okay. Finally we got something interesting. And also 60, 62, 64. These are a bit more readable. Yeah. So we need to automate a bit auto fmt xdate here. And then we need something like tight layout, whatever it does. Let's copy and paste it and see how it goes. Yeah, not that bad, I would say. And at the end we can say, yeah, I want to save this, so we're going to save it into, yeah, let's save it into the data, because I already know how to access this one. It would be PLT save figure here, and just name it plot data with test split .png, and the DPI would be 300. Yeah. Did we save it? Some kind of refresh or something. Let's see. I'm expecting that I would find it here. Opening Explorer, data, and it is saved here. Yep, true. Okay, removing this one and continuing further. So split to train test set. This one is markdown. Just to check, okay, were we always using 2? Yes. So how to split to test and train set? I said that this one should be the train and this one should be the test in order to forecast. Okay, so train equals df, take everything but the last 4, and test equals df, that is last 4 to the end. Yeah, true. And now predicting historical mean is the next step. Okay, so we simply name it historical mean, and then we say okay, it's NP mean, and then we use the train data. Yeah, pretty much that's how it is. And then if we want to see the historical mean, we see it, it's 4 something, which means that the absolute average of return per share or income per share, or what was the original thing that we named it, earning per share, EPS, is somewhere around 4 for the whole period. It's not a lot. On the other hand, I would, if I'm was an investor or something, I would be not happy to have 4 when, okay, somewhere here I would be happy, but in general, like forecasting, it's obvious that it's going this way up. So it's bad, but this is literally the most naive way to make forecasting. So let's consider it. So test dot log, and pretty much we're going to add another column, which is going to be called predicted mean, and we are going to put historical mean there. And if we take a look at the test, you see, like for everything we have it like here. Well, it's not good. I wouldn't say it's good. I mean, instead of 16 we say 4, instead of 14 we say 4, instead of 11 we are saying that our earning per share would be 4. So that's not the best one, but let's continue. So there is something called mean absolute percentage error, which is mean absolute percentage deviation, is a measure of prediction accuracy of a forecasting method in statistics. It usually expresses the accuracy as a ratio defined by the formula. So it sounds like a complicated formula, but it's not. Let me show you how to write it. So def map y2 y predicted. So it's true versus predicted, and then it makes NP mean of those, of course, taking the absolute value, because it doesn't care where we compare with positive or negative, like not being able to give a good forecast is not being able to give a good forecast, independent on whether it's good or like on a plus or on a minus. I can give you an example here. So map, let's say our true value is 100 and our predicted value is 80, we get 20. So 20 is really kind of low, but not that kind of low. I mean, pretty much the true value is 100 and we get 80, so 80 multiplied by 1/4 would be 100. If it was the other way around, just to give you the difference, if the true was 80 and the predicted was 100, it would give 25. So you see that in order to get the true value from the predicted, we should reduce our predicted value with 25%, e.g. with 20. So that's how the things are with the map. So map historical mean, in our case map test data versus test predicted mean for all of those is 70, which is not great. Yeah. And yeah, let's plot a bit more stuff. I'll just use a bit of copy paste and rewrite it and change it wherever I need it. So this one is okay. And from here almost nothing is okay, so I'll start adding stuff. So add plot train date train data G with a dot and a minus, and I'll label it train. Yeah. Control and something close to the left shift does this. Just printing a bit, and we see what we just got. Just like minus dot, minus dot, minus dot. This is because of the G minus here. The next two things I'm going just to copy paste them. So it's again the date, but this time the test date, and the test data, test date, test predicted mean. Let's see it once more. Okay, this is how it looks. This is our real data, and this is our predicted stuff here. So setting labels, something that we already did. It's here. You see already this one here. Okay, this span there. Yeah, slowly working there. And then we probably need the xticks. Yeah, we have even the years, which is beautiful. These two are also important. And as end, I have something like this called a legend, and it's in location 2. Axis object has no legend, has no attribute legend, so it's because of the missing D. Legend. See, like the locations, if you say location 1, it's here, location 3, it's there, and location 0 is where location 1 is. Okay, makes sense. Yeah, and at the end, let's save it, and we're going to name this one predict historical mean. Plot data with historical mean, and if we wait a bit, we will find it in my Explorer. Yeah, data with historical mean. Yeah, here. Okay, so far so good. So the next part of the book, it explains that probably we should only go for the last year mean, which would bring us something. Yeah, I mean, let's see, 1296 is the last year mean. Definitely better than this thing here. so it will be somewhere here. And adding this beauty to our test table. Yep, we have it predicted mean and predicted last year mean. Yeah, not bad. And when we map it, the result here is 15 compared to 70. Yeah, I guess we are closer to 0. So let's do it again, but this time I'm a bit tired to do everything once more. So I'm going to make this one here a function. I should have done it probably before, but def plot my forecast, and let's just think what actually we are giving. We are giving we are giving test and train. Yeah, test train. My years. Yeah, it's okay. My function years. Don't think about anything. Okay, my function years and fig and ax. It's just shadowing the one from outer scope, so that's why it's not happy. But what can we do? Actually, it's this one. Should be like this. So actually the test and the train are okay. We just have to give a column. And let me think. Okay, so column equals predict this thing here. I'm just thinking, and if we say def, not def, but we now call it plot my forecast, and the column is column, the one from here. I mean, I'm not going to put it like this, but on a new one. And let's see how it is going to look. I think it's okay. Okay, I'll just call it here column.png. And I think these are the only things that are variables between this and that and the one that is in the book. So let's start. Yeah, so you see the predicted is here. That's kind of okay. I'm just curious whether we got the one I'm looking for in the Explorer. Did we get the third one? Yeah, and it's even named nicely, predict last year main penalty. Great. Just deleting this and deleting that. And we continue. So the last thing we can do is we can take a look at the last known value. Why do we need last known value? Because sometimes the last values are the best. So what we can do is actually rather easy. I would say let's go here, copy paste, and say predict last known value. So this last known value will be used for anything in the future. That's kind of the most naive forecast that I have seen, and I know, but it is used. I mean, it can be used as a benchmark. If after a lot of fancy changes you cannot come up with something better, then your prediction is really bad. So yeah, you can use it as a benchmark for last prediction. So that's our last known value minus 1 from the train data, just to let you know how the train data looks like. So yeah, this is it, 99. So this is what we took, pressing twice D to delete stuff, and then we say, hey, I'm going to add this to our column, to our small table called predicted last, and it will be with the last. And this is how the test looks. So we have the predicted mean, we have the predicted last year mean, and we have the predicted last. Yeah, not bad. I mean, the table looks bad. The predictions are really, they are naive. So for naive predictions, they're okay. So of course we put the map last, and it's called map function that I already explained. Test data test prediction last. Yeah, and of course I want to see what's there. Nah, it's not good. 30, it's disgusting, I would say. But anyway, let's plot it. Column predicted last, plot my forecast column. And this is how it looks. Simply takes the last and puts its values here. Yeah, not that bad. And the last thing that we are provided actually is something a bit more interesting from the book. It actually says that we have like a really serious seasonality here. It's obvious that in the last month we have fallen down, but in general the trend is going up. So what we can do that will actually give us some good results is if we can simply use the predict last, but in a seasonal manner. So for this one we put this one, for this one that one, for that one this one, and for this one that one. I mean, I think that if I do it here, I'll just say, okay, so to predict this here, we can use this value and simply we'll put it here. To predict this one here, we put this value. To predict this one here, we put this value. And to predict this one here, we put this value. It's not that bad. It wouldn't be exact, but it would be a good prediction. So let's do it. It's called naive seasonal forecast. It is naive, it is seasonal, and it is forecast. So yeah, let's go. So test.log, we call predict last season, and here we should train the data -4 dot values. Test. Yeah, it happened. Actually, this is the pre-last, the last season, last season, last season, last season. Yeah, it works. So the map naive seasonal equals map test data test predicted last season, and then map naive seasonal data from object is not callable. Yeah, most probably I just want to sleep. Okay, map test. Okay, it's this thing here. 11, which is not bad, and this is the sum of all wrong predictions, which is kind of okay, I would say. Let's take the name of our column here. Predicted last season is the name, and forecast it. See, the red one literally copies the green one, but although it is like this, it's probably the closest we have, and it's actually close to the blue one. I mean, depends how much you are into money, but it is close into earnings per share of Johnson & Johnson. Okay, and let's finally make some kind of summary here. To see which of the naive methods is the best. In our case, this is the best one. So X would be the form method, which were historical mean, then last year mean, then just the last year, and then the naive seasonal that I just discussed, and the Y's are pretty much 17, 15.60, 30.46, and 11.56 for the naive seasonal. Okay, then X bar, X, Y, and we need some kind of a width that we can play with, and we can put 0.4 or just 0.4. Set X label. This would be called baselines. With other words, if we ever perform worse than this in our methods, then we really should rethink our ideas about forecasting. I mean, these are really the easiest things. Map in percentage, and AX set Y lim 0 to 75. Let's already see. Okay, baselines. Let's write those a bit with the 70 here, this one here, and the other ones. And do this with a loop for index value in enumerate Y. Y is not in English. It's in Latin, I think. POT text. X equals index. Y equals value plus 1. S equals string value. And H equals center. Yeah, beauty. If we put here left, let's see. See, all the numbers are in the left, and if we put right, they would stay in the right, but center is the best. Would it understand if I write it with British English? No. Supported values are this. center, right and left. Okay, I'll pick the center. Okay, tide layout is something that we'll need. And save figure. So POT, save figure, and it should be in the data baselines.png. And that's all, folks. Once again, if you want to buy the book with a discount, probably you can use my code if you want. Thanks you for watching, and I know this is my first video since probably a lot of months, but I hope there will be more. So enjoy your day. Bye bye from Vitush Academy.